In the dark, frigid void beyond Neptune lies a vast and mysterious region, where the ancient remnants of our solar system's birth drift silently through the darkness, perfectly preserved by the deep freeze of space. To reach this shadowy expanse from Earth, we must travel past the rocky planets, flying by Mars and then beyond the swirling storms of Jupiter and Saturn. Farther still, out beyond the blue giants, Uranus and Neptune, we finally reach our destination. Welcome to the Kuiper Belt, a vast ring of icy debris encircling our solar system like a frozen halo. This isn't just a collection of distant rocks. It's a time capsule from 4.6 billion years ago holding the untouched building blocks of our cosmic neighborhood. It is home to several dwarf planets and mysterious objects that have left many astronomers scratching their heads. I'm Alex McColgan, and you're watching Dark Matter File Star. Join me today as we explore the worlds lurking in the shadows of our solar system and piece together clues about its history, about planetary formation, comet activity, and even the origins of life. Before we knew for sure that the Kuiper Belt was real, astronomers suspected that something existed beyond Neptune. For decades, everyone's favorite dwarf planet, Pluto, was thought to be an isolated object in the outer solar system, but something didn't add up. Its small size and unusual orbit suggested that Pluto wasn't alone, and that maybe it was merely one of a number of yet-to-be-discovered distant objects. In 1951, astronomer Gerard Kuiper predicted the existence of a belt of icy objects just beyond the orbit of Neptune, but without telescopes powerful enough to detect these objects, the idea remained theoretical for decades. That changed in 1992, when astronomers David Durrett and Jane Law discovered the first confirmed Kuiper Belt object, known as 1992 QB1. Pluto and its moon Charon were both discovered before 1992 QB1, Pluto in 1930 and Charon in 1978, but these objects were only confirmed as KBOs after the 1992 KBO. Since then, more Kuiper Belt objects have been identified, populating this distant region beyond Neptune. To grasp the true scale and position of the Kuiper Belt, let's imagine we're traveling in a spaceship, starting from the Sun and moving out towards the outer edge of our solar system. And as we move along our journey, let's compare the Kuiper Belt to both the more well-known asteroid belt and the less well-known Oort cloud. Starting near the Sun, we zip past the rocky planets, Mercury, Venus, Earth, and Mars. Between Mars and Jupiter, we see the asteroid belt, made up of the leftover materials from when our planets formed. A thin, spread-out ring of rocky debris, the asteroid belt is about 2.2 to 3.2 astronomical units away from the Sun, and about $1 wide. As a reminder, 1 astronomical unit is equivalent to the distance from the Sun to the Earth. Most of the known asteroids reside in this part of our solar system, ranging in size from the largest asteroid, Vesta, at 525 kilometers wide, almost the distance from London to Belfast, to the smallest objects, some of which are just tens of kilometers across. However, despite residing in such a large space, the total mass of all of the asteroids in the whole asteroid belt combined is only about 3% of the mass of the Moon. Beyond the asteroid belt, we encounter the gas and ice giants Jupiter, Saturn, Uranus, and Neptune, colossal worlds that dominate the outer solar system. Finally, as we pass Neptune's orbit at $30, we reach our destination. An even more remote, icy frontier, the Kuiper Belt. This vast expanse stretches from $30 to $50, and is home to a range of intriguing objects, from frozen relics of the early solar system, to dwarf planets including Pluto, Haumea, Eris, and Makemake, and countless other smaller objects. Like the asteroid belt, the Kuiper Belt contains ancient debris from our early solar system. In fact, Kuiper Belt objects are considered some of the oldest surviving pieces of our solar nebula that originally formed the planets of our solar system. And so, at one point in the very distant past, these stray pieces might have been able to come together to form yet another planetary body. However, Neptune's gravity prevented the icy objects from coalescing and never allowed them to form something new. Unlike the asteroid belt, which is primarily made of rocky material, the Kuiper Belt consists of mostly frozen methane, ammonia, and water ice, forming a frozen, thick, donut-shaped ring of debris. The Kuiper Belt contains hundreds of thousands of large icy bodies bigger than 100 kilometers across, and more than 1 trillion comets, not to mention smaller debris and dust. And the average distance between objects is so large, it can be hard to imagine. Each of those objects is on average, between 0.02 to $0 and 10 cents. Imagine, 10 million kilometers between objects. Here, in the dim outer reaches of our solar system, these icy bodies drift in near silence, preserving vital clues about the origins of planets and comets. But it doesn't end there. That was just the main region of the Kuiper Belt. Overlapping the outer edge of the main region is another area of the Kuiper Belt called the scattered disk, which continues out to nearly 1,000 Australian dollars, with some Kuiper Belt objects on orbits that reach even farther beyond that. So while the asteroid belt and Kuiper Belt share some similarities, as you can see, one is vastly more expansive than the other. And while we may have reached the end of the Kuiper Belt, there's still another massive structure that surrounds every other object and belt that I've mentioned so far. In a recent video, I talked about the Oort cloud, the colossal structure of orbiting icy debris that encircles our entire solar system. It's so jaw-droppingly far away that even our most powerful telescopes can't catch a glimpse. So how do those two structures, the Oort cloud and the Kuiper Belt, differ from each other? For one, the Kuiper Belt is thousands of times closer to the Sun than the center of the Oort cloud, which is theorized to stretch from around 2,000 to 100,000 Australian dollars. Another major difference is that the Kuiper Belt is donut-shaped, while the Oort cloud is spherical, like a gigantic bubble of swarming debris. But something these structures do have in common is that they are both sources of the celestial phenomenon that we know as comets. The Oort cloud is the source of many long-period comets, while the Kuiper Belt is where some short-period comets are born. While the Kuiper Belt today is one of the most massive structures in our solar system, it's just a small fraction of what it once was. Originally, altogether it probably contained 7 to 10 times the mass of Earth, but the shifting orbits of the 4 giant gas and ice planets caused most of that to be lost to space. What remains is no more than about 10% of Earth's mass. Not only that, but the Kuiper Belt today continues to slowly erode away. As objects occasionally collide and break apart, smaller fragments are left in their wake, and some of the resulting dust is blown out of the solar system by the solar wind. Sometimes these collisions, or Neptune's gravity, will cause Kuiper Belt objects to head on a new path toward the Sun, creating short-period comets, which have orbits of less than 200 years. Over time, the Sun's radiation causes comets to shed material, producing the spectacular tails we see from Earth. Several famous comets originate from the Kuiper Belt, or its scattered disk, including Halley's Comet with an average orbital period of 76 Earth years, or comet Shoemaker-Levy 9, which broke apart and smashed into Jupiter in 1994, in the first ever observed collision of two solar system bodies. As we all know, Jupiter survived, but the impact was visible from Earth, and was quite a spectacular sight to behold. You can see it for yourself, if you check out my video on the aftermath of this collision. You may also have heard in the news recently about a near-Earth asteroid named 2024 YR4. While there,